Hello everyone, welcome to another Monitoring Power Hour. This week, or this month, we're talking about everything T4D web. So thank you all for attending. If at any point you cannot see the screen or cannot hear any of the presenters, please enter a comment into the chat window and let us know if there's any technical difficulties. As well, throughout the entire webinar, feel free to ask any questions on the material and we will answer those as we go, as well as we'll have some time at the end to answer those questions. So with that, we'll dive right into the content and starting with your presenters today. So myself, Riley Smith, I'm with the product marketing team in the monitoring group here at Trimble, and I'm joined by Jesse Huff. Jesse, go ahead and introduce yourself.
Hi everyone, Jesse Huff. I'm with monitoring sales in the geospatial sector.
Perfect. All right, and the agenda for today. So we'll spend a few minutes at the start talking about an overview of what T4D web is, where it's used, and why it's important in the monitoring process and in the system. And then we'll get into the workflow that we'll be covering in the following live hands-on demonstration, which will be the bulk of this webinar. And then towards the end, we'll have a section on resources and what you can do next if you would want to get some more information on T4D or Trimble monitoring solutions in general. And then we'll have some time for questions and answers at the end as well. But we'll also answer questions as we go through the presentation. So with that, to recap what we've done so far in the Monitoring Power Hour, so we've covered different aspects of the entire monitoring system. We're starting with the different types of sensors, so total station, optical sensors, GNSS, and geotechnical sensors, as well covering T4D server on the configuration, storage, and data management portion. And so that brings us today on the web application, which is T4D web, about visualization, analysis, and alarming of that monitoring data. All right, so an overview of T4D web. So if you're not familiar, the way that I summarize T4D web is the ability to communicate sensor data in a useful way. So it's easy enough to collect data, but what can we do with it? How can we make decisions from it, and so forth? And break that into three categories. So the visualization aspect, and this is all about the taking that data and viewing it in different ways, whether that's a map view or some kind of custom view that you've created. And then the analysis about generating the data set that you want, whether it's from a chart or a scatter plot of that various sensor data. And then the third point is about alarming and setting those thresholds to trigger notifications. So someone, a human, can interact with the system once a certain threshold has been exceeded. Now, just to note, a more of a logistical thing, if you are interested in T4D web, this is available in the T4D advanced perpetual license or subscription offering, and we'll talk a little bit more about the layout and edition structure of T4D at the end of this webinar. So starting with the workflow, and this we're going to cover in detail in the hands-on demo, but to preface it, we'll go over it step by step. With T4D web, first it's all about starting with the sensors and sensor management. And this is about checking the data flow all the way down to the sensor health of all the various sensors you may have on your monitoring project, which could be optical sensors like total stations, could be GNSS, and could be geotechnical sensors and a variety of other data that can come in. Moving on, we look at user account management, and this is about who can access the monitoring system and at what level of access can they have. For instance, you might be the administrator of that system, but you might also want to give a client or a stakeholder view-only type access so they can see some of the charts and the data, but not actually change anything in the system configuration. And then analysis, this is all about building the data set that you want to see. So we have all of the sensor data, but what is it really you're trying to get out of it? Is it just a vertical value? Is it a three-dimensional position? So user-generated data sets from the sensors. Fourth is alarms. So an automated monitoring system, I think we get distracted by the automated term often, but an automated monitoring system does not necessarily mean it's maintenance free. The whole point of a system, automated system, is to trigger user interaction to make a decision on the data that's being collected. And then finally, reports. This is about providing transparency of the system and reporting on all of the things that we've talked about in steps 1 through 4, as well as a variety of other things, and understanding the health of the sensor, what users are in the system, the data that's being analyzed, and as well understanding what alarms have been triggered or not. So with that, we've covered the overview, and we're going to jump into the hands-on demo now. So what I'll do is transfer the presentation rights to Jesse. So bear with us for one moment while we get this set up. In the meantime, if you have any questions, feel free to type them in. All right, Jesse, I can see T4D Web now.
Excellent. Thanks for that overview, Riley. Everyone, this is an actual live demo, so please bear with us. This is not a recording or anything. We are going through this live. But anytime you've got questions, you want to dive deeper into something, please don't hesitate to speak up and let me know. Happy for this to be as interactive as you guys would like it to be. So going to the workflow that Riley just mentioned, this is the home screen for T4D Control. We are logged into our Westminster demo site, which is running live in real time in Colorado. I'm logged in as a system admin. You can see up here in the corner. This is current time and date. And the home screen brings us to sensor management. The first screen that you come to when you log into the system is the home screen. You can see on the left-hand side over here, we've got green lights, which means it tells us at a glance for sensor management that everything is okay based on the parameters of our system. Now, as we go through this demo, we are going to change some of these system parameters and see if we can get some of these lights to change colors. Based on various thresholds that are set by the user, these lights will go from green to blue to orange to red, depending on what level and what conditions have been met or exceeded within the system. Sensor management, everything in a monitoring project is a sensor, whether it's a total station, whether it's a GNSS receiver, whether it's manual data entry. We create everything as sensors. So you can see the number of sensors that we have in this project. Here at a quick glance is 15. We have 2 alarms in this project. One alarm is okay. It has not reached an alarming threshold based on the user input, and one of them is disabled. We have 0 unacknowledged events. We do have, when we get to the alarming part of this, we do have the ability to require acknowledgement from various user groups. And the current sensor data flow, we have 15 sensors, 2 GNSS receivers, 11 target position sensors, 1 temperature sensor, and 1 total station. We are running this as an integrated survey in Colorado, which means it's a combination of GNSS and total stations being used in real time. From the home screen here, as you look across the top of the screen, you see sensors, data entry, and sensor groups. This is where the heart of the project starts. Sensors, this is where we configure sensor information. You see this corresponds to these here as well. You can get to anywhere in the system from the home screen. You can get to anywhere in the system from your menus up here. It just depends on your personal workflow and what you prefer your flavor to be. So from a sensor management standpoint, we're going to bring up the sensors and all of the sensor information that's here. You see we have, this is page 1 of 2 of the sensors that are here. We have temperature sensors. We have prisms. Everything has its own sort of icon here. Total stations have a total station icon. GNSS receivers have a Trimble rover. Prisms have the 360 prisms that are there. So for each one of these, the traffic light control is live. If at any point an alarm is triggered or an alert level is triggered, these icons will change color, both here on the left and in the map view. You can see for any one of these, you can drill deeper. It's a web page. You can drill deeper into each one of these. The current state is fine. Where the location is, the current lat and long, local coordinates, in metric here. From here, we can get to map views. We can view charts on the latest observations. We can see what the latest observations here are. We have the ability to add images and documentation to the sensor state here. If these sensors were installed in somewhere that we needed additional documentation, you know, if there were an access code to get through a fence into where the sensors are managed, we can store all of that information here so that it's there and visible for individual sensor images or any documentation associated with it. The sensor information. So this is the overall view and how we want to see essentially the default charts that come with the system. So we set this for the system. These are universal settings going across each of the receiver types. And for this particular project, we're displaying delta height and delta 2D for GNSS integrated survey, delta height, delta 2D for post-process GNSS positions. We can change these, we can add to them, we could not display the height and display the northings, for example. And that's what the default charts will come through as. For purposes of a demo system, and because I am the system administrator, I'm not going to change these just because in the real world, we tend to think about positions in a 3D vector, you know, horizontal and vertical movement, things like that. So that's what we have on display here. Target positions work the same way. You can see we've got the same thing selected for target positions here. Temperature positions, degrees Celsius, we can enter that data. We can change the defaults. We could go to Fahrenheit if we wanted to. Same thing with the total station. So we can configure all of these differently so that we could have terrestrial targets, prisms that are being measured that display northings and eastings, and GNSS receivers that only display height. It's completely customizable by the user based on that sensor, the sensor management of what is needed for the current monitoring system. So in our workflow, we have all of the sensors. We have data entry. We don't have any manual data entries in this current project, but we do have the ability to do so. Just about any data type can be manually uploaded into the system for use, whether it's level data, whether it's manual observations, whether it's readings that were taken with a tape measure in the field. We provide an Excel template. You simply fill that out, you put your data in it, and you upload it to the system. We can create groups of sensors to make sensor management much easier. Groups of prisms, groups of GNSS receivers, groups of integrated surveys. You can see we've got these sensor groups that are here. We've got 2 buildings in Westminster. So we've got sensors that are grouped into these groups. These are 3 that exist on building 1. And you can see which analyses these sensors groups are a part of as well. The next critical component, once all of the sensors are configured, is the user account management of a monitoring system. Various stakeholders for any monitoring project are going to need different levels of access to the monitoring system. There are some going from, you know, the very end user at a high level overview. It may be an end customer, you know, it may be a government official that needs view only access. You may need several system administrators. You may need several people who can create analyses and actually get in and work with and manipulate the data. So we're going to come over to the administration tab here, and we're going to go into user accounts. Now you can see on our left here, I'm logged in as the system admin, so I've got access. I can see everything that's in the system. There is a standard default system administrator account. You see that we have the other users that are in the system here. It doesn't display my name because obviously I'm logged in as me here. But these are the users we currently have in the system. We can add new users simply by stepping through a role. We can add an email address and phone number and a name and what role we want assigned to those people. These are the current roles that we have. And once I click register, that would send the email out to the user that I created. That was my email address that's in there. You can see that I've played around with the system here that's stored in my computer cache to have my email address pop up just for system testing. But all of these users may need different roles. So these are the roles that we currently have. An admin is by system default built in. You have to have an admin of the system. So you can see there's not an edit or a delete button here. The other ones that come with the system can be completely user definable. The analyst, we could go in and edit the role. We could delete this role. But everything that we add here is user definable. So we could say, let's create one that's called power user. I'm a terrible typist, just so everybody's aware. So we've given it a name, and now we give it permissions. Now, this is all graphically done, so it's checkboxes, and this prevents you from creating a role that has incorrect parent and child relationships. So you can't inadvertently create part of an account that can do some things that are linked to other things in the system. So we can view, create, edit, and delete. Now this is for the data and the sensors and everything else in the system. So if we want a user that can, let's say the power user can view the account settings page, they can edit the SMS gateway configuration. They can edit when we click edit here, everything else becomes available to create those right parent-child relationships. We want them to be able to edit the chart page, the same thing with the composite view and the custom view page. We don't want to do anything with license server settings. We can view the live update. We can create logs. We'll go through what each one of these things mean. But you can create, you see as we start clicking up here, these become available down here as well for view. So let's, and web page. Let's turn on webcams for this power user. So we simply click save. Here's the name, power user. It's now live in the system. We've configured a brand new role from scratch. So when we go back to adding a new user, the role is now available here in the dropdown, and it's that easy to create a new role as the system admin. So once you have all of your users configured, all of your accounts configured, you can add as many users to the system as you would like. It's a web page front end, so you can have multiple users accessing the system at the same time, which is fantastic. You could have a system admin who's going in and doing administrative tasks with the system, adding users and accounts, while analysts and view only people are using the data in whatever way that their role defines for their position as a stakeholder. So once we have all of our user account created, we can add to them at any time. We have notification settings. We have both email and SMS gateway configurations. We are not running an SMS gateway currently with this. This is just the email server configuration here. So we do get live notifications through. You can see my roles here, my email address at Trimble. I want email only notification, but we have all notifications you can pick and choose. So this is all part of the user management. We can add projects and roles. We do have the ability to add multiple projects. We are just in the Westminster demo site project right now, but you can add that with your user configuration as well. So once your users are there, we have a power user created. We're going to follow workflow and into number 3 on the analysis and charting, actually getting into using the data that comes in from a monitoring system. So if we click the charting and analysis tab, the first place that it brings us is to the charts. These are the system default charts. This goes back to those settings that I was showing a few minutes ago, where we've got delta 2D and delta height that are displayed for prisms, for example. So you can see we've got color-coded delta height that we can toggle on and off, and delta 2D from this parking lot position. Y-axis is set in meters, and the time frame that exists here. We can zoom in on this data. We can export the data directly from here to either a total workbook or just a CSV file. We can change how we want that displayed. I prefer to look at splines just because it's more pleasing to my eye. We can refresh interval. We can set this to never. We can refresh it every 10 minutes if we would like, and you can see the count down here when we're going to refresh that data. We click hide controls again. We can zoom in on the data. You can see because I changed it to spline, it's a nice smooth fit spline to the data set. These are just the defaults that are built into the system. As we step down the charting and analysis tab here, we come to the scatter plots, which as a surveyor, I find very, very useful. As a geospatial person, I find very, very useful because it gives us an overview over time as to where, if any, drift is happening. So you see we've got a slider bar down here. We've got y-axis of delta northing and an x-axis of delta easting. We can change this to height over here as well. And this slider bar, you can see over time, each shot that has been taken in this time frame, going back to August the 12th, you know, about 7 days ago. And the value per day is the way that we're graphing this. So this is outside of our deltas that are set. So you see it comes in color-coded orange. As we go through the system, there's one that's within threshold, so it comes across as green. There's one that's even more green. So the values change. The colors change based on the values, but it's really nice to be able to see this over the default days. You have complete control over your color displacement. You can link the axis scales. You can show the tooltips. You can export all of this data again from here directly into Excel if you wish to further scrutinize it in your own way. When you really start to get into the power of the system, we get into the analysis configuration, which is number 3 on our workflows here. So as a system admin, I can choose to see all of the ones that have been created here. But if there are users in the system that have created their own analyses, system admin has rights to see all of those that are there. We're displaying all of them right now. You can see Roland Chin, who's one of our support engineers, and myself have created a few that are in here. We're going to add an analysis here in real time and step through it. And because we used it before and I'm a surveyor and uncreative, we're going to call it Power User Chart. We're going to give it a normal chart just for sake of charting. We have these options though. We can create a new heat map, normal charts, which is essentially a line graph, bar charts, cross sections, tab analyses. We have all of these options that we can go through. Show logs. I'm a big fan of showing all of the logs in the system. Everything in the system can be logged, from time alarms were created to times that new analyses were created, and we can show those on the data set interactively. So if there was a power outage and somebody logs into the system and says, hey, you know, between August 19th at 8 a.m. and 10 p.m., the power was out to the system, that can get logged in the system and shown as a bar, you know, or a dot or a little book. There's several options there in the data itself. So if there is a break in the data, right there in the data set gives you the explanation for it.
Hey Jesse, with those various analysis type charts, is there like specific situations where you might use one over the other?
There is, and a lot of it is driven by the monitoring project itself. Heat maps are very, very useful, especially when you're looking at large data sets. You know, you may have a situation mining, for example, where you've got 100 prisms on a high wall of a mine, and you don't want to see every little data set that's coming through from the prisms. You just want an overall view of the heat map that's there, taking all of that data into account. So that could be part of your analyses that you need to report on as well, where those heat maps are. When we get into the reporting, the analysis becomes a very integral part of the reporting also. My experience has been that the normal charts are probably where most people live, just because it's the most common usage of the data sets. But certainly cross sections, things like tunnels, tunnel convergence and things like that being computed in a cross section chart, a cross section analysis are very, very useful. Railway corridor alignments, things like that.
Very cool. Thank you.
You can see the logs here. We can line dots or a little book icon or an area. I tend to keep mine on the little icon there on the books, which you can click on in the data set and have it open. We can have a scope here of private and public. If you make the scope private, then it's only available to that particular user when the other users log into the system. Now, this goes back to the owner over here. Because I'm a system admin, I can see everybody's even private analyses that they've created. If I make this public, it's available for everybody who logs into the system to see, provided that you have permissions to see the analyses. We can go a fixed date range for this one. This is roughly the last 7 days. We can enable time windows so that if you're only monitoring, you may be monitoring in real time, but you're only monitoring for 6 hours a day. Well, you may not need to see all 24 hours of that. You can just go from 6 a.m. to 4 p.m. over the last 7 days. And that gives you your data set, which, really cleans up the data set from there not being data for several hours. We're going to leave this off for the time being, just because we are measuring fairly frequently out here. We're going to save this analysis. So this is in here now. We can add series data to this, which allows us for every sensor that's in the system. It allows us to configure the analyses going all the way through. So we're taking this data type here of GNSS integrated survey and temperature. We have both of these available to us currently. And we're going to go multi-sensor with this. And we're going to pick a few of these sensors. So we're going to go TS04, and I'm just randomly picking these. We're going to add, let's go with 5 of them. We're going to add these 5 in here. We can go observation series or velocity series on the data. So this is observation series creates essentially delta on XYZ axis, and velocity series is computing velocity based on values per day in linear regression lines. Velocity is very, very useful in a monitoring scenario. We do both velocity and inverse velocity in our analyses, which is inverse velocity is a fantastic indicator of failure times and used to predict when failures are going to happen. For purposes of this demo, we're just going to keep it with delta XYZ. So we're going to say observation series. And all we do is we simply click through the wizard to create these. We can go multi-columns on the data, the values for the columns. I like to look at things in 3 dimensions, and we are really concerned about the northing movement for this project. We can apply a filter to the data source. We can plot every epoch that's been measured or value per day. So we can take the summary of that entire day, if it's 10 rounds that have been measured, or 10 different GNSS observations, and amalgamate those into just the value per day. We'll go every epoch with this, just so we can actually see some of the data set that's here. Line type, again, I'm a fan of the spline. Units, the SI unit is meters. Because we are looking for movement, I prefer to look at it in millimeters. And to 3 decimal places is perfectly fine. Anything more than that just becomes mathematical calculation. So we can go absolute and relative measurements. Let's look at absolute for this rather than just the deltas. And we click done. So the system computes, the series data is in here. We can click view, and the analyses, the first time that it comes up, it'll take it a second to load because it's going back through and processing all of this data. But we're going to get the data on our chart here, on an interactive chart, very much like the one that we saw before, that has all of this information on it. You can see we can turn these guys on and off for the various data sets. We can start a live update. We can apply regression and exclusion lines to this. So if we just pick one of these, for example, and let's pick one of the red ones, just because it's easier to see and provides us with more contrast. So now we're down to just every single epoch on this particular data set, which is WC201. So that's building 2, prism number 1. We can fit a regression line to that. And you see right here, it brings up, it's going down through this data set at 0.512 millimeters per day. So that's a linear best fit through the data set that exists. If we need to exclude points, like if we think that this is an outlier, Here, we can pick the same data set and we can exclude various points from the data set just by simply clicking on them, and the regression lines will fit accordingly. We can change the color of our regression lines. Black and red seem to be a good contrast, but we could go something different. You can turn it yellow. You have complete control over this. We can create a copy of this from here for another analysis. So you find an analysis that really works, you go through the time of creating one, you can create a copy of it and continue adding to. This is my analysis, so I'm going to add series data to this. That's great that we have all of that information that's there, but let's see what the movement is relative to the temperature data. So we have one temperature sensor that's in here. We can obviously select multiple sensors, but we only have one temperature sensor that's in here. If we have 4 of them in a project, then we can select all 4 of them, just like we did with the prisms. We want every epoch that's measured, value per day or value per hour. We'll keep it like for like, so we're comparing apples to apples here. We can put a spline in with this also, and we're gonna go absolute measurement. So this gives us the actual temperature in degrees Celsius all the way through. We click done, this adds series data to this. We can come back and click view, and you'll see once it loads on the value on the y-axis, we go from just having displacements to also having degrees Celsius in the same chart that exists here. So we're going back through for the last week's worth of data and getting all of that data amalgamated for the chart. The first time that you do this, it will take it a second to load up, but again, this is happening in real time. So now you can see this value here and how the temperature data affects each one of the data sets that are here. So I simply clicked and dragged to zoom into the chart. They are interactive. So these tooltips come up, you can see what the delta, northing, easting, and height is. We do run standard deviation filtering as well. So you can see some of that information, and you can compare that directly to what the temperature data was at that particular time. As the temperature data comes through, you start to identify trends. These points do exist on top of a building, and we do try to get enough of the data set fluctuation in the data set so it's not just a flat line that comes across the charts. But you can see you can add any type of series data that you want to for this. Any sensor that's in the system can be combined in the analyses to create these rich visual data sets that provide you in-depth analysis. We can add multiple analyses together. We can create composite views out of our analyses. The one that we have created in here now is one that Roland created. You can see all of the points as they sit. So this is looking across the top of building 1 in Westminster. The total station sits over here on the corner. You can see that we're displaying scatter plots on this one. You can hover over the various icons and get what the current displacements are, what the current temperature is, the sensor data flow, and we've got a time slider bar down here where we can see all of this over time change as well. So it provides an overall comprehensive view at a very quick cursory glance to tell you what's going on with your system. Adding composite views, just like with user account managements and with most everything else in the system, you step through the wizard, how you want to see a layout. You could lay out 9 different panes if you wanted to. You could have, we'll go a simple 2 panes here just for quickness. Both of these panes are empty. We click simply on the edit button and the element type. So we want a chart or an analysis. Let's go with the analysis that we have. Power user chart, the one that we just created, is available in there. So I click done, and we can come over here and we can add a scatter plot for the parking sensor. That's fine, it's there. All of the sensors are available. We can pick a different one just so it's changing. That's there, we've got both of those, and we simply click view. Again, the first time that you create it, it'll take it a second to load, but that entire analysis that we created is there and it's available. It's still live, it's still interactive. You can come back up and show controls. You can change your line widths. You can get your range information. All of this is available with the slider bar over time. Oh, let me hide this so that you can actually see. So you can see as the scatter plot comes, we're on the same time window for both prism charts and for the scatter plot for that particular point. So it gives you the direct correlation between the two.
Hey, Jesse, question for you. Is there ways to share this composite view once it's created?
Absolutely. It can be public or private, just like the charts. You can enable public access and simply click save. So that way everybody that logs into the system has access to this now.
Cool.
Just on the view. So if we come back over on the view here, it's all there. And that's publicly available. Every user in the system can now see this just like they can with Rollins.
Awesome.
Which takes us to number 4 in the monitoring workflow, creating alarms and notifications off of all of this data that we are analyzing and collecting and configuring with sensors and charts and analyses. So we come over to the monitoring tab here and we pick on alarms. And like Riley mentioned a little while ago at the start of the session, the whole idea behind generating alarms and alerts with a monitoring system is twofold. It's supposed to trigger human interaction for somebody to make a decision. Now, obviously, there are cases, certain thresholds that have to be met, that maybe you want to trigger alarms, alerts, you send emails, maybe you want to trigger flashing lights and beacons and things like that. All of that can be done through the alarming module here. But the whole idea is to trigger human response from this. So just like with the analyses, you'll see that we follow the same workflow here. We've got the one disabled alarm, if you recall from when we started, and we have a no data alarm, which is currently okay. We're getting data from all of the sensors. We want to add an alarm definition. You guessed it, we're going to use power user, and because that saves me from typing as well. We're going to call this a demo alarm just so that we know where it came from. We set our evaluation frequency here. Currently it's set to 10 minutes, which for me I feel is a good way to set it. You can set it to higher, but this means that the system every 10 minutes is checking for change in these conditions. What this doesn't mean is delay after an event happens in order to trigger an alarm. It's just the evaluation frequency that we're checking the database. We can set condition merge order. We can go in sequence and before or is where I feel like most of the users are most comfortable, just because it allows simple Boolean logic, binary logic, to create very complex alarming scenarios. So if we save that, you can see this looks very similar to how it does in the analysis view. We've got an alarm name. We simply add conditions to this. So if we want to take a specific sensor, let's say we want T-Box, TO4, we'll pick a couple of these at random again. We'll put 4 of them in here. Now this is where we can specify on alarms, even based on these conditions, we can still have the opportunity to go back and specify whether it's the observation monitor or the velocity monitor that exists here. So these alarms are both attached to and independent of the analyses that have been created in the system at the same time. We'll keep it observation monitor just for simplicity. I'm going to leave it at Delta Northing because I'm going to see if I can get our traffic light controls to change colors for us here. On the latest available value, we can go the average of the last values. We can set alarms based on the peak values or the peak local mins and max. We're going to keep it the latest available, so we're evaluating essentially the last round that came in. We'll keep it absolute measurement just because that's what we've been doing for the purposes of this demo throughout. This is evaluating, you know, actual XYZ versus relative to some type of other point. Units, again, I like to see things in millimeters. I'm hoping that on the building that we are detecting small movements, not meters of movement, because that would be bad. We can set any type of logic here for comparators. You know, X is greater than equal to Y. You can pick these as needed. 3 decimal places, and we have three thresholds here. So the attention threshold will start to change color in the system and start to give the user and everybody in the system going, you know, hey, something's hit this alarm status here. Maybe you should start looking. Warning turns everything the amber or orange color, and the alarm threshold turns the traffic light control into red. So we're going to set these very tight. I did go in and see what we needed to set these at to get some color change happening here, just for what it's worth. So these are very small values based on a millimeter, you know, 1, 2, and 3 millimeters. We click next and step through the wizard. Do we want standard deviation filtering? There's a whole topic about why this is there and how this works, and getting into the 3 sigma values and really some of the science behind the geodesy with this. In terms of this simple alarm that we're creating, I'm going to leave this to no. Setting this too low, if you turn it on, it can cause no data alarms. Just you guys can read what's on the screen there. I'll leave it up there for a second. But it applies to standard deviation, so that we can go with standard deviation rules in terms of evaluation of the alarms. Enable no data alarm. I like to turn this to yes, just because in my monitoring systems, I really want to know if there's not data coming through. So if we're measuring around, let's say we're measuring total station rounds, for example, and we're measuring 1 round per hour. Well, let's say I want to know if we don't have any data after 2 hours, because that means that we've not just missed 1 round, that means we've missed 2 rounds. This is completely user definable. The trigger threshold type, I'm going to leave this set to any, but this is where logic can start to become very, very complex within the alarm evaluation. We have these options. So we're going to set this to any, that way any of the values that are created in any of the conditions of this alarm are going to be triggered. If we set it to all, and we've got 5 different conditions in there, then all of those conditions have to be met before the alarm will be triggered. Same thing with percentage, and same thing with count. If we've got 5 different conditions here, you know, over here in our list, we can set it so that we don't trigger alarms until 50% of those conditions are met, or 2 out of 5 of those conditions are met. We can show this on the map. We'll go back to the map here in just a second so you can see the overall view, but we can create a heat map based on the alarm thresholds that are here, even on the interactive overall map that's done there. So when I click done, you can see that this immediately turned red here. No data threshold is 2 hours, so that means that's fine. We've gotten our data back within 2 hours, and all of these conditions have been triggered. Because this is red, this means that we've reached the alarm threshold for this alarm. Now, this alarm is not enabled. This color coding right here is just telling us what's going to happen as soon as we click enable the alarm. Configuring the alarm, we create notification messages. We can change the granularity of this, sensor status changed, alarm status changed. We can send customized messages or just the system default messages. For the alarm messages, you can type in whatever you want to here for the warning messages, and you can set these so that they're custom. I'm going to go back and turn these off just for simplicity, but you can certainly send through customized messages. You simply click done. So we've got our messages there, and who do we want to notify about this? Just because he's got some stuff that he's created in here, we are going to notify our friend Riley, as well as myself that's in here. So we click done. We can trigger batch files with the alarm if we want to. You can write your own batch files to trigger socket connections, state-specific files, the alarm change. You create these batch files so that you can actually action other things within a system, connect peripherals to the system, trigger phone calls, warning lights, things of that nature. And you can see the entire alarm history for the power user here. We've just created it, so there is no history here. But in a week's time, we leave this here, and all of the alarm history will definitely be here. So you can see we clicked through, and I just came back over here and clicked, and everything is still here as we needed. I'm going to click Enable Alarm. So now we're actually loading these alarm, and you can see it's immediately gone to the alarm state here. When we come back over to our sensors, or in home, you can see now we've got 4 alarms that have gone off and the number of alarms in the project. So we've gone from everything okay to alert level. If we come over to our map view, or even go back into sensor views, we go into our map view here. You can see that we've got our power user layer that's in here now for a heat map, but you can see the sensors that have been triggered here. We've got a prism way out here at a tee box on a golf course from the Trimble building, and you can see which one of these sensors are alarming. The 3 dots here tell us that there are more than one sensor that exists here. The more that we zoom into these, the more that we can see these. So the delta height here happens to be it hit the alarm level because I set it so low. And there's 2 sensors here. You can see TSO4 has turned red and B1 temperature is still green because we have not set an alarm threshold for that. But as soon as you click enable, everything becomes active and color coded for the alarms. What the alarm logic allows us to do is to create very useful conditions to this. We can disable the alarm for editing. You don't want to edit live alarms because you're changing conditions that are there, so it requires the user to say, disable. We can add a different condition to this. And we can add as many of these conditions where we want to. So this is where the merge operator and comes in. So we've got that, let's say temperature, we only want to trigger this if the temperature of the only temperature sensor that we have on the latest available value reaches 50 degrees Celsius per day. I'm going to set something here that just absolutely is absurd for Colorado. I will turn on my no data alarm for temperature, let's say every 1 day. If any of these conditions are met, again, show on map. I'm not going to show this one on the map because it's just temperature data and we're adding as a condition to our existing alarm. So you can see this one stays red because this has been met, but this one stays green because everything is okay with that alarm. When we enable this alarm again, we're going through all of these conditions that have been met here. This is where we could go back and say, rather than saying any condition has been met, say all of these conditions have to be met. We can click on each one of these and go back in and edit the trigger type threshold, all of the conditions. We simply click done. You can see that it's still here. And when we enable the alarm, we can change the logic by which the alarm is there. And you see we went from alarm status to OK status. Even though the thresholds have been reached, the condition of the alarm no longer has been met, which means that we haven't exceeded one of the values that are there. We go back in, we're still at these thresholds that are here, but the alarm itself is still okay. So the values are still displayed, but we're not going to trigger batch files or emails or anything like that because those alarm conditions haven't been met. Once we have that configured, we come to the last part of our workflow here, reports.
Hey, Jesse, before you move on to reports, one question. So
Sure.
with that first alarm you created, I think you set me as one of the recipients of notifications.
Mm-hmm.
Would I receive an email or a text message? Is it based on the account settings that we had set up
Yes.
earlier in this?
Yes, that's correct.
Okay, cool.
And if we had put custom messages in there, like depending for alarm, you know, I typed in there, "Hey, look at me." If we had left that on, that's the message you would get from the system.
Very, very good. Cool.
Once we have our sensors configured, we've got our user accounts worked out, we built our analyses, we have our alarm logic down. Obviously, we want to know what's going on with the system as in an automated process as possible. So we have report schedules. These are the current ones that we have configured. You can see that they are in fact disabled. The report settings, you can put your own logo in here for your individual company if you would like. For the report schedules, we're going to add a report schedule. We're going to select a report type. So we've configured alarms, we've configured analyses, a system status report. Let's do an analysis report. We went through all of the trouble of creating an analysis. Let's create a report based on that. I'm going to use Power User because it's in my dropdown. My schedule period, I want this report weekly at 8 a.m. Tuesday morning. My report options, I do want the charts. I want you to go ahead and send me the data through. I don't want to include the series on this one, just because. The number of recipients, we can add recipients based on the roles here. We'll put the power user in here because it's the power user report, and we can select individual people here as well for these. I'm in here by default because I'm creating it, and we'll add Riley to this one as well. Riley, you'll have to remind me to go back and turn all of these off so that we don't get flooded with emails. These are all of the analyses that have been built within the system. You can see we've got the power user chart down here that we just created, when it was created, the date range that's there, who created it. We click save. Every Tuesday morning at 8 a.m., I'm going to have this report waiting for me in my email inbox.
The question that came in for you, Jesse, regarding reports. Let me just expand this. So can you generate a public URL for a certain report that you've created and share it with someone?
A public URL, I'm not sure I follow.
Yeah, I think the question is if we generate a report through T4D Web, are we able to share that, or what are the ways we can share that with someone?
Right now it comes as a PDF. If you need to share it via URL, just create a user account for them and share the web page. Is the typical workflow there. But yeah, it comes through as a PDF. I included the series data with this one, so it'll come through with a CSV file as well. But you could add them as a user with no rights, you know, to send them the email report. Also, you can have as many recipients on that notification list as you would like. Does that answer your question?
I think so. Yeah. If it doesn't, feel free to elaborate, and we can look at that question again.
So you can see it's that easy to create a report. We can add as many report schedules as we would like. The alarm reports, the system status report, we can see, get an overview daily at 6 a.m. So it's waiting for you at the office before you even walk into the office as to what the daily system status is. You could open your email and never even have to log into the system theoretically. That takes us through the end of that for reporting, and just about right on time. Are there other questions?
Yeah, one just came in. Is it possible to create your own customized report from Rosen?
You can select the data that goes into it, and you can create your own analyses and the way that that's displayed, but the order in which it comes in is set by the PDF format. So there are certain ways to customize it based on whether you're reporting on an analysis or a chart or something like that. but it's really a case-by-case basis.
Very good. I think that's all the questions for now. If anyone does have any other questions, feel free to type it in while we have a few more minutes. And with that, I can switch the presenter back here to me. Bear with me 1 second. All right. I think everyone can see that again. Perfect. So thanks, Jesse, for that great demonstration of T4D Web. So I want to summarize everything we've talked about so far over the course of this webinar. So we gave an overview of T4D Web, which is really about visualization, analysis, and alarming of the monitoring data you're collecting, whether that's geodetic sensors like total stations, GNSS, or geotechnical sensors, more like crack, tilt meters, things along those lines. And then the workflow of how you step through setting up and getting the end deliverables set up in T4D Web through the sensor management, next on to user accounts who can access and how, the analyses, getting the data set you want for your specific project and application, the alarms and who's notified by them and what triggers them, and then the reports and what you want to report on and the schedule as well for those reports. So some more information and resources to kind of tie up the end of this webinar. So for everyone, if you're not aware, we released a new version of T4D in July, and so it's available, and we've changed the structure to suit different situations for monitoring projects and be more flexible on how T4D can be used on various types of monitoring projects. So we have a 3-tier edition structure, and going in order of feature set, we have the field, intermediate, and advanced. And I mentioned at the start that what we've shown here in this demonstration was T4D Web, which is included in the advanced edition of T4D. We also introduced 3 and 12-month subscription terms. So in the past, it was perpetual license of T4D. We still have that if it's suitable for the project, but we also have 3 and 12-month subscription terms, which are very useful, especially if the monitoring project is a short term and you only need it for 12 months, let's say, instead of a full-length license. And a variety of other geotechnical workflow improvements and more features, and you can see those in the release notes on our website if you'd like to. And you can download T4D version 6 from the Trimble monitoring website. If you have an existing license of T4D and you're under warranty, you can upgrade to version 6 right now if you want. Also, there is a current promotion to upgrade to reinstate if you're not under warranty with T4D. So I suggest if you're interested in getting to the new version of T4D to contact your local Trimble distributor and they can help you get that set up. So now in terms of resources, some information if you want to find out more or you want to get a little bit more information on specific products in the monitoring realm. So we have a new monitoring.trimble.com website. I suggest everyone take a look at that, as well as our YouTube channel, which has got a lot of how-to and tutorial videos on setting up different pieces of whether it's T4D or even the sensors. And we also have a monitoring community. This is meant to be our public essentially forum. So if you have questions or you want to talk about a project, feel free to type in Trimble monitoring community and you should be able to find that on Google pretty easy, and it's available to the public so anyone can join and contribute. And then also this question was asked earlier. We do record all of these webinars and you will receive an email shortly, maybe I think it's in roughly a day, you'll receive that email with a link to watch this recording. If not, you can also go onto the Trimble Geospatial Webinars page and find the recording for all the monitoring hours, as well as all of the Trimble Geospatial webinars that we've done in the past. And as always, if you have any specific questions or you want to maybe get a more in-depth demonstration of T4D or see where it can be used on your next monitoring project, I suggest you reach out to your local Trimble distribution partner. And with that, for our next series of Power Hour webinars, monitoring Power Hour webinars, we're planning on having the next one September 16th. So mark your calendars. We'll be at the same time. And we're going to switch focus. Our set of webinars before this have all been about the specific components and pieces of the monitoring system, whether that's the sensor or the T4D portion. Now we're going to look more at application and industry type monitoring series. So looking at different areas and how monitoring systems are deployed in various industries, such as the ones that you see here. And with that, I'd like to thank everybody for joining the webinar. I'll just take a quick look to see if there's any questions asked since I've started talking again. I think we've answered most of these. Yeah, custom reports, alarming. Good, I'll give about one more minute to see if any more questions come in. Perfect. It looks like Jesse, we've done a good job. Maybe we've answered all of them. I want to thank Jesse for taking the time to do such a great demo of T4D Web. Any last thoughts there, Jesse, from your side?
No, I hope everybody's still awake. I hope that we don't have questions because it was informative, not because everyone is sleeping.
Regardless, if you do have questions or anything, feel free to reach out to us or your local Trimble rep, and we can chat more further. So I appreciate everybody's time, and enjoy the rest of your week and stay safe out there.